Let's balance this reaction. But we're going to make it more complicated. We're balancing it in acidic media. Now, what makes it more complicated? If I look at everything I've got chromium, I've got oxygen, I've got hydrogen, I've got nitrogen, I've got oxygen again, etc. So I've got a whole bunch of stuff. But the thing that noticed right off the bat is there's a hydrogen on this side, but there's no hydrogen anywhere over here. And so the idea here is anytime we're going to balance a reaction, we have to say, okay, in order to find more hydrogen, is it in neutral media? If it's in neutral, there's going to be some water that can donate and help balance this. If it's in acidic, we're going to have some extra protons flying around. If it's in basic, we're going to have extra hydroxides. And so acidic basically tells you, you can use water to balance, you can also use hydrogen ions to balance. If it's basic, you've got hydroxide ions and you've got water. So really that's the only extra step. But in answering these types of questions, I actually break it down into a whole bunch of steps. If this helps you, great. But here's what I'm going to do, and feel free to pause this and write it down. My steps that I'm going to take is I'm going to write the half reaction. I'm going to balance every element other than oxygen and hydrogen. Then I'm going to balance my oxygens first by adding water to whichever side I need to add it to. Then I'm going to balance my hydrogens by adding protons wherever I need to add them. Then I'm going to balance my charge by adding electrons. Then I'm going to balance the electrons across the half reactions by multiplying. Then I'm going to do the final same step that we just did on the previous problem, where I'm going to add the reactions and cancel out my common terms. So my first step is write my half reactions. Okay, so I've got chromium over here and I've got chromium over here. I'm pretty much just going to ignore oxygen and nitrogen for the moment. Not going to worry about them. So I've got chromium and I've got chromium. So I'm going to do the same thing I did before, is I'm going to write it out and I'm going to leave room to let stuff happen. Then I'm going to do the same thing for the nitric acid, or nitrous acid. So that's my first step, writing my half reactions. So all I did there was decide, that looks like those two kind of, chromium probably came from that chromium, nitrogen probably came from that nitrogen. I'm not really paying attention to my oxygens and hydrogens right now. Why? Because we can pull them from water. Okay, so that's my first step, write my half reactions. Next step says balance any element that you have other than oxygen or hydrogen. So what do I have? I've got chromium over here and chromium over here, but there's two over here. So the first thing I have to do is make sure that I have two chromiums on this side. I have one nitrogen here and one nitrogen here. Those are fine. The next step says balance out my oxygens by adding water. So over here I've got 7 oxygens. So I need to add water. How many waters am I going to have to add in order to balance out my oxygens? Well, here I have 1. If I make that times 7, now I have 7 oxygens and 7 oxygens on that side. Awesome. Over here I have 3 oxygens and 2 oxygens over here. So I'm going to add plus 1 water over here. Because now I've got 1, 2, 3 oxygens and 3 oxygens on this side. So I have now balanced out my oxygens by adding my water. The next step, balance your hydrogens by adding protons. So up here, is it balanced? I've got my chromiums balanced, I've got my oxygens, but nope, sure isn't. I have how many hydrogens over here? 2 times 7, I have 14 hydrogens. So I'm going to add 14 hydrogens to this side in order to balance it out. Down here, I have no hydrogens over here, and I have 2, plus 1 gives me 3. So I need to add 3 hydrogens to this side. Okay, so that's all you're doing, is you're saying what's there, what needs to be there, and you're adding them to whichever side you need in order to balance them out. So let's kind of stop for a second and check and make sure everything's balanced. So in this equation, I have 14 hydrogens on this side, 14 hydrogens on this side. 2 chromium, 7 oxygens, 7 oxygens. Here I have 3 hydrogens, 3 hydrogens. 1, 2, 3 oxygens, 3 oxygens. 1 nitrogen, 1 nitrogen. So now all the atoms are balanced. Before you ever start playing with the electrons, you have to make sure you balance out the atoms first. Now we're on the next step of balance out the charge by adding electrons as needed. So let me switch to a different color because I want us just to remember how we did this. So on this side, for instance, so we're just going to look at this first half reaction. I have plus 1 of hydrogen times 14, so that's 14 positives, plus negative 2, and there's only one of them. So I have plus 14 minus 2 gives me a total net charge of plus 12 on this side. Over here, I have 2 times 3 gives me a positive 6 plus 0, so plus 6 on this side. So I'm basically going from plus 12 to plus 6. So how do I balance that out? If I add plus 6 electrons to this side, then I'm subtracting 6 electrons or 6 charges over here. It's going to give me a total of plus 6 on this side. So I just added 6 electrons to that side. Now we can come down here. So remember, so now we got plus 6, charges balanced in this Happer equation. Now come on down here. Water is 0. This is 0. So it's 0 on this side. What about over here? I have 1, a negative 1, and I have 3 positives, plus 3. So that gives me a total of 3 minus 1 plus 2. So I'm going from 0 to plus 2. So what that means is I need to add on 2 electrons on this side to give you minus 2. So now I've got 0 on this side, 0 on this side, and now it's balanced. But wait, there's more. So let me switch to a different color. How about red? Alright, so we're not entirely there yet because the next step now says to balance the electrons across the half reactions by multiplying. So this is the same step we did on our simpler half reactions. So there's 6 electrons here and there's 2 electrons here. So how do I get to have 6 electrons in this bottom one? I'm going to multiply this whole reaction by 3. So if I do that, this becomes 3, 3, 3, 3 times 3, 9, 3 times 2, 6. So now I've got 6 electrons here, 6 electrons here. Now I can add them all together and cancel out as needed. So adding them all together. So I've got 14 hydrogen plus Cr2O7, 2 minus, plus 6 electrons, plus 3 waters, plus 3 HNO2, yields, and I'm just going to have to put this on a different line just because I'm running out of room, plus yields 2 chromiums, plus 7 H2O, plus 3 NO3 minus, plus 9 hydrogens, plus 6 electrons. Okay, all I did was I brought everything down, and if it was on the left side, I kept it on the left side of the arrow. If it was on the right side, I kept it on the right side of the arrow. So now I need to figure out what does each side of the reaction have in common, meaning there are 6 electrons on this side, 6 electrons on that side, so they're going to cancel out. What about my hydrogens? I have 14 hydrogen over here. Use a different color. I have 14 hydrogens on this side, and I have 9 hydrogens on this side. So if I do that reaction, which one's going to have more? The left side has more. So there's 14 over here and 9 over here. That means these 9 are going to go away. 14 minus 9, I'm going to be left with 5 hydrogen. Okay, so now my electrons have gone away and my hydrogens have gone away. What's left? I've got water on both sides of my equation. So I've got 3 waters here and 7 waters here. So what that means is all 3 of these hydrogens are going to go away. 3 of these are going to go away, leaving me with 4. 7 minus 3 is 4. The last and final step is just rewriting it all. So meaning I now have 5 hydrogens plus chromate plus 3 HNO2 yields 2 chromiums plus 4 waters plus 3 nitrates. That is my final reaction. I then always recommend a couple things. Let's go back and make sure the charge is correct. So meaning, what is my net charge on the left side of the equation? What's my net charge on the right? So I've got 5 positives from my hydrogen, 5 plus a negative 2 plus 0 from the nitrous. Then I have 2 times positive 3 is 6, 0, 3 times a negative 1, negative 3. So 6 minus 3 gives me plus 3 on this side. 5 minus 2 gives me plus 3. Is my charge balanced? Yes. What about my molecules, or my atoms? I have 5 hydrogens on this side, plus 3. I have a total of 8 hydrogens on my left side of the equation. 4 times 2, I've got 8 hydrogens right here. Chromium, 2 chromiums, 2 chromiums. What about nitrogen? 1 nitrogen, 1 nitrogen. Oxygen, 3 times 2, 6, plus 7, that's 13. What about on this side? 4 plus 3 times 3 is 9. So 9 plus 4 is 13. Is that what I said before? I hope so. Yes, I did. Perfect. That means we're all good and balanced. Check. Those are the 2 kind of checks I would always do. Alright, so the last thing I might ask then is which one of these equations was an oxidation reaction and which one is a reduction. Because up here, we've got these 2 equations. We've got number 1 and we've got number 2. So my question is which one is an oxidation reaction and which one is a reduction reaction? So remember, if you got electrons on the left side of the equation, that's reduction. If you got them on the right side of the equation, that's oxidation. Or another way you can think about it is originally you went from a positive 6, you went from 12, a positive 12 was what you were originally at before you added the electrons, to a positive 6, so you were reduced. Here it went from 0 to, originally it was at negative 2. So this one on the left side, that's reduction. So number 1 is a reduction half reaction, and this one is an oxidation half reaction. Okay. And then down here we have our net redox equation.